This is the idea of replacing animal studies for drug testing, for example, with little microengineered devices that are lined by human cells and reconstitute organ-level functions.
One of the things that pharmaceutical industry is finding is that they're having very high failure rates, and often it's because the animal models being used to develop these drugs are not predictive of the human situation.
It's very expensive to perform animal studies and also time consuming.
Whereas here we have models that can potentially better predict the human situation.
It's called human breathing lung on a chip, and this device mimics a breathing human lung.
It has human airway cells from the air sac on a membrane that's porous. On the other side of the membrane are human capillary blood vessel cells. There's air on one side, there's flowing medium with human blood cells in it, like blood on the other side, on the capillary side, and then the whole thing stretches and relaxes just like our lung does when we breathe.
And we mimic, various types of physiological responses to drugs, toxins, or various types of materials we encounter on a daily basis.
So this would be very useful because it's human relevant, because we will be using human cells.
And I think the beauty of this technology is so easy and straightforward that a lot of people can use it without getting trained, especially biologists, clinicians, chemists, who don't have any engineering background. This technology is accessible to them.
Much cheaper than using animal models. To see the size, you need very little compound. So this would not only be more predictive, but have higher turnaround times. You can screen using much smaller amounts of the drugs too. So more predictive and more practical.
But we also have kidney on a chip, bone marrow on a chip, peristalsis gut on a chip, and we're just going on organ to organ and hopefully integrating them. In a little microsystem, we link the heart that beats to the lung that breathes. We're getting great interest from pharmaceutical industry and hope to announce our first alliance to use those to see if we can indeed replace some animal studies to accelerate the drug development process and decrease costs.
This institute is by far the greatest and best working environment for bioengineering research, and we can predict the behavior or response of these cells or the body to, for example, drugs more precisely. I think that's where the promise is.